presentation go? And if all else fails, so the material is split into two parts. The one in red there is the material that you actually are going to need in the hands-on part of the tutorial. And then the bonus material is useful stuff. If you don't get it today, then we'll find a way to get it to you some other day, or after I stop talking, you can come up here and load it off of my machine. If nothing, bring your own USB stick if nothing else works. But anyway, I'd like to get started in the talking part of the tutorial, and as I said, it's on the web there for the essential material. So this is maybe an unusual style of tutorial. I don't know if you've ever been to one before. I've never been to one before, where I'm going to do some talking for maybe an hour or so, and then really the rest of the time is going to be for you to take that the software that we've been talking about and play with it, and basically do whatever you like with it. There is a structured set of tutorial lessons. And so in order to get you, and they're supposed to be completely self-guided, so you don't really need me for those, but I'm going to take you through the first tutorial lesson just so you get used to them, and then I'll leave you to your own devices. So certainly by the time we reach the coffee break, I will have completely stopped talking, and it'll just be up to you to spend as much time after the coffee break, or as little time as you like, just sitting in here playing with it, writing your own search code, coding up your own domains in PSVN, or doing whatever else, running pattern database heuristics on your favorite planning domain. If you aren't used to pattern database heuristics, there's code for doing that that's in one of the tutorials, and so on. So there's just lots of fun things that can be done, fun for search people, and so you just have to choose your own fun thing and do it, and I'm here just then as a resource to help you if you get stuck on something. So one thing I need to make clear from the very beginning is that when I use the word PSVN, I'm actually referring to a collection of different things. They all integrate, but there are 4 different things that all fall under the umbrella of PSVN. So the one that immediately always comes to my mind first is the language. That's where it all started with, was a declarative language for defining state spaces. And this is very similar to SAS+, which I'm assuming you're somewhat familiar with, but I won't rely on that, but I assume you are. So it's very close to SAS+, but it has one extra thing that actually turns out to be a powerful extension, even though it too is very simple. So there's a language called PSVN. There's also an API that we call the PSVN API. It actually has nothing to do with the language at all. So even if you hate the language, you might love the API, or you might love the language and hate the API, whichever way you go. But these two things have no connection to one another. They just happen to both be in the PSVN system considered as a whole. Connecting these two things in the system that I use is a compiler that takes statements in the language and produces C code that implements the API. And so the compiler in the system we're working with today, the compiler is the glue that connects the language to the API. So, and it honestly is a compiler in the sense that it creates C code. It doesn't create some kind of intermediate code. And then, of course, you run a C compiler on that to actually make it run. And finally, there's a whole suite of software, most of which has been written mostly by other people that sit on top of the API. So these are search algorithms of various kinds and other things that just assume that there's an implementation of the API, and they just are, IDA star and greedy best first search and all those favorite search algorithms of yours. Those are all part of the PSVN software suite. And maybe it's important to be really clear that PSVN itself is not a planner or a search algorithm. It is only just exactly what you see here on here. It's a language, an API, and a compiler, and then user-contributed code that might do search or planning, but you could use your own code down there. It's not. There's no commitment to any kind of search in this whole system. I always like to start a talk with take-home messages in case for some reason you decide to leave early. You'll at least know what you need to know on the way out. And so the first one is you might ask a question. We have PDDL, we have SAS+, maybe we have a few other options. Why do we need anything else? And I guess what motivated me to do this is that I found that first-order languages were somewhat intractable to reason with, and grounded languages were sort of overkill. They were overgrounding, but nobody could figure out how to ground things out in another way. So why not just represent things in a natural way? And it turns out there's a sweet spot in between fully grounding and first-order representations. There's a sweet spot that exists in languages for defining state spaces. And there may be details about the PSVN language that you don't like, but the thing to really remember and to take home from this is that there is a sweet spot. You don't have to fully ground things if you're not going to do a first order representation. There's something in between that is as efficient really to reason about as the SAS plus, but in some cases exponentially smaller. And so, so that's what I mean by a sweet spot. And so PSVN is one such language. Functional strips is another such language, which was in the planning community but seems to have been forgotten. Anyway, so, and you could invent your own language that was in this middle spot too. So there is a middle spot that I think is the ideal place for us to be operating. The second thing, so that's about the language. The second thing is about the API. And again, you may not like the details of the API, but I think the important thing that I've learned, especially working with the fast downward people, Florian and Pomeranian here, and I've been working very hard to hammer out all the details of this API, is that it really facilitates software use in a big way. As soon as you have an implementation of this API, all the code that's been written that's sitting on top of the PSVN system can now sit on top of a planning on a PDDL system or an SES plus system or anything else. So the huge amount of software that's been written. And I think we need to do more of this in the community. I mean, how many papers did I see at the workshop yesterday? And I would think to myself, I would love to have that right now. I don't want to re-implement it. I want to just, he's got it implemented. Why can't I just take it and stick it into my system? And the answer is because we haven't had a lingua franca where we could share things at some level. And so now we've got this API where there can be sharing going on. And so the Fast Downward team has implemented the PSVN API. So all the user code that was only exclusively for PSVN people can now run on top of the PDDL and other things that the Fast Downward system does. And vice versa, I can now take all my user code and run it on their system. So it's actually a big, and if you, I know I'll get to that later. Anyway, so this is a take-home message. It's not that this particular API is God's gift to mankind, but that the AN API is something that the community should be striving to have. This one is kind of limited in its scope. It was meant for a specific purpose, but maybe we should start thinking about other APIs for other aspects of the things we all are doing in common. The third take-home point, which I'm afraid if you do leave early, you will have no idea what this means, because I can't explain it until we know a lot more stuff. But there is a third take-home point, and it's only 5 letters. PSVN generators are a good idea, so there you go. That's a take-home point. And of course, I'll explain it in full, but that'll be a little while from now. For those of you who are just arriving, there is a USB sticks with software on them that you want to grab. And I'll just go back here because I won't keep doing this, but I'll just go back here. There's actually 2 things on that stick, and the one in red there is the one you really need. And the one called bonus material is 700 megabytes. It's a bit big, so you may not want that. But the one called PSVN 2014-0620, that's the file you want to grab if you're going to do any of the hands-on part of the tutorial. Okay, so that's PSVN, that's the take-home messages, we're finished.
Anybody else need a USB?
Okay. I've got a couple extras. Chris, do you want to just come up here and grab one? Yeah, of course, I'd like those back at the end, but if somebody sits down beside you, then continue with them. The other thing I want to mention is that I'm actually very excited about PSVN, and so I'm going to spend quite a lot of my research time over the next few years maintaining and extending PSVN. And if you look in the bonus material, you'll see 3 bits of software that are being distributed today. And I feel a little bit bad about that because there's so much software that's almost ready, but I couldn't quite get it in the neat, clean, well-documented form that I wanted it to be in for distribution. But there is a lot of stuff that's imminent. And so if you think there's only 3 bits of software in the suite, then that's a bit misleading. There's a ton of stuff. Here's a laundry list of it. I won't go through it all or explain what it all is, but the slides, by the way, are in the bonus material. If you want to track along and you've got the bonus material, the slides are in there under documents. So anyway, there's a lot of stuff that's about to come, and in the next year, probably in the next 6 months, half of this stuff will be there. It's just a question of me getting around to cleaning it up. It all exists. Everything on this slide exists in a kind of a beta form, but I'm not quite ready for prime time, so I didn't distribute it today. Okay, so you can imagine now the presentation I'm going to make is there's these 4 parts, the language, the API, etc. So there's going to be 4 parts to my little presentation here before we roll up our sleeves. And I thought I would start with the API because I really want to emphasize that it's separate from the language. So we can talk about the API. I can tell you everything you need to know about the API and never mention the PSVN language. And that's why I put this one first. So everybody knows what an API is, and in the material, the main material, not the bonus material, under documents, you will find 3 documents. There's the PSVN manual, there's the API manual, and there's the software suite manual, manual for each of the big parts. The API manual, like any API, the manual defines the types and the constants of the functions that anybody who claims to be implementing the API, the PSVN API, must conform to, must have these functions and types and constants, and must conform to what's required of those things. They're supposed to provide certain functionality. But one of the interesting things is, how do you make an API so that on the one hand it nails things down very specifically, and on the other hand you can have a rich set of different implementations. So this was the challenge that Florian and I went through, because they're working in C++, they're doing everything at runtime. I'm working in C and doing everything at compile time. And so it's quite an interesting challenge to come up with an API which was as specific as possible and yet still allowed them to do their implementation and me to do my implementation. And so what you'll see also in the manual is that there's very careful, we tried to be very careful documenting what variation was allowed between one implementation to another. And so that's all documented in the API manual. And then the API manual is going to have an appendix for each implementation. So right now the poor fast downward guys were scrambling to get other things together and didn't quite manage to get their appendix written in time. So the only appendix there right now is for the PSVN2C, the compiler that I've got here. But there will be appendices added. And if you implement the API, then let me know and send me an appendix. It's a short document that just says, I was allowed this kind of variation and I did this. And I was allowed this kind of variation and I did that. And so it's actually a rather short document, but it's important for people who are going to use the software to know what's going on. By the way, this is meant to be extremely interactive. I know I've done all the talking so far, but if there's ever a question, don't save it till the end to ask me right away, because there's a whole lot of material to go through and it's all kind of varied. So as I mentioned, there's actually 2 very different implementations of the API right now. The one that I've got, which is out of the compiler there, PSVN2C, and then the fast downward folks have their implementation. And I can't speak too much to the details, the internal details of it, but Florian is here, and if you have any questions about that, then you can catch him at the break or something. So just so you don't think this thing's magical and powerful, it is the most obvious thing in the world, because remember, what its real purpose is just for allowing you to generate states and test if states are our goal. And so this slide all by itself shows you, I would say, a third or a half of the whole API. And this is the code you would write in C for iterating through a state's children. So the first thing you see at the top, the things in bold are in the API, and the things that aren't in bold are just regular old C. So you can see there's type definitions, there's a type for states, and the way that PSVN API works is you go through the children of a state one by one. So you have an iterator for going through the children. You ask for the first child, and then the next child, and the next child, and the next child. And so there's a type for that kind of iterator. And then you get into the loop here, and you initialize the iterator, and there's 2 things you say when you initialize the iterator. There's the iterator. Okay. You say, what state are you going to generate the children for? And you say whether you're going forward or backward. So those are the 2 things that you say about, because PSVN supports some, anyway, let's not get into the details. So anyway, that's how you initialize it. So far, you've got no children. The only thing that's a little bit different about this iterator is it doesn't actually iterate through the children. It iterates through the rules that are applicable to the state. And so you can see that there's a thing called next rule ID. This doesn't return a child, it returns the ID of an operator. Oh, I used the word operator and rule interchangeably. So anyway, it gives you an index for the next operator that applies to this state. And then if you actually want to get the child, there's another thing in the API that says apply this rule to that state and get you the child. So you probably have written this code a million times yourself, not using exactly those same function names, but you've probably written something extremely similar to this in any planning or search algorithm you've got, because any state space algorithm basically iterates through children. So now you've seen about half the API right there, and you can see there's nothing scary about it. It's just the obvious thing done in a particular way. I already mentioned quite a bit about what value is added by having an API, so I will skip over this slide pretty quickly. The basic idea is the software reuse. Anything written on top of the API can be used with any implementation of the API. That's what APIs are for in computer science generally. And and so here's just an example of some of the things that are in the material that you've got today. So A star, ID A star, actually A star isn't is not quite in there. It's all the building blocks are there, but I don't think there's actually an A star. There's things like A star, but not quite A star. Anyway, IDA star is definitely in there. GBFS with the FF heuristic is in the bonus material. Code for generating pattern databases is in tutorial number 3. Stratified search is in the bonus material. So that's all stuff that's actually maybe sitting on your computer right now if you got the bonus material. And as it says at the bottom, Uncle Sam wants you, your code could be here in this list, and I would love it if it was. So if you ever do implement something in the API interface, then let me know and I will add it to the list here. So that's what this slide is all about. It's about saying that I've gone through the process of taking some existing code that wasn't written for the API and changing it. And it turns out that the pieces that you need to change are very localized usually, and very small localized changes in order to use this API rather than just doing whatever you were doing ahead of time. So there are some exceptions to this, but in a lot of cases it's not a lot of work to change to this API. And so why not do it? And then those bits of your code can be shared with the whole community. Now, of course, if you do that, then you have to find an API implementation somewhere. So again, it's actually not too challenging to write it yourself. Most of the discussion we had with the fast downward people wasn't talking about how they would implement it. It was talking about how to define the API so that they could implement it. Once we had the API defined, then the implementation is actually pretty straightforward. And I think that would be true for anybody out there who's got a planning system, that to separate it out isn't actually the hard part. And so I think that, or of course you could use the fast downward implementation, or you could use my implementation. So that's all there is to say about the API. It's very simple, nothing scary. You'll get to know the whole thing in about 10 minutes once you start working on it. So now let's talk about the language. The language is extremely simple, and in many ways it was just the first thing that occurred to me. But and this was in 1999 when it was first developed. But as time has gone on, I've been thinking about it a little bit more systematically, and I had design objectives in mind. So the first thing is I'm a big fan of finite domain representations, and so it is a finite domain representation language. Also, it just turns out, being a heuristic search guy, although I think this comes up in planning a lot as well, that it turns out a lot of the domains you end up swapping things around. Things move from here to there, or two things get exchanged. So I just wanted to make sure that that could be compactly expressed, and that's actually the addition on top of SAS+, is it's much easier to do this in PSVN than it is in SAS+. The other thing is this was a personal language that I'm now starting to share with folks. So the things that I wanted to be able to do easily are the things that I was researching. So I'm always interested in bidirectional search and backwards search generally. When you build a pattern database, you have to go backwards. And so I wanted a language where it was very easy to go backwards as well as forwards. I'm an abstraction guy, so I like making abstractions. One thing that's emerged a bit more lately is I want to be able to reason symbolically. What I mean by that is about partially specified states. This isn't really taken to the limit that it could be in PSVN, but the language itself is actually extremely easy. Because of the semantics are so nice, it's very easy to reason about partially specified states. And finally, of course, I always had this idea that there was going to be a compiler, and I wanted to make sure that the language was not so powerful that I couldn't generate efficient code from it. So efficiency was always really at the forefront here. So you finally get to know the secret. What does PSVN actually stand for? That's what's in the title here. There's an old technology called production systems that goes back to the late 60s, and I was always a bit of a fan of production systems. So it's production system as the PS, and then there's a vector notation, which is slightly cumbersome for humans, but it is a very efficient thing to implement. So production system vector notation is what PSVN actually stands for. So as far as the vector goes, that's what you're going to see on this slide. Everything's going to be a vector of a fixed length n. So a state is a vector of fixed length. You have each entry in the vector I call a state variable, and it's a strongly typed language. So each variable has a finite domain of possible values, and the domains are non-intersecting. Each operator is, in the planning world, you would call them preconditions and effects. I call them preconditions and effects too, but from a production system point of view, they've got a left-hand side and a right-hand side. And I actually prefer to call them left-hand side and right-hand side rather than preconditions and effects, because when you reason backwards, the right-hand side becomes the precondition and the left-hand side becomes the effect. So I'm constantly talking about the left-hand side and the right-hand side. When you're going forwards, then the left-hand side is the operator's precondition, the right-hand side is the operator's effect. These also are vectors of length n, so that the state is a vector of length n, and a left-hand side is a vector of exactly the same length, and a right-hand side is a vector of exactly the same length as well. And in each entry in a left-hand side and each entry in a right-hand side, you have only two options. You can either put a constant from the appropriate domain, remember the strongly typed part, or you can put a variable symbol. And the same symbol can occur more than once. Same symbols can occur multiple times on the left-hand side, multiple times on the right-hand side, multiple times on the left and the right-hand side. And we'll see a few examples now. And so the semantics will become perfectly clear after just a couple of small examples. Here we'll have a vectors of length 4. So in these examples, every time you see a number, it's a constant, and every time you see a letter, it's a variable symbol. That's not part of the language. That's just a convention I'm using on the slides here. If you wanted 0 to be a variable symbol, good luck. You know, that'll probably confuse everybody who looks at it, but you can do it. There's no restrictions at all on the tokens. Any token can be anything. Anyway, so there's, you can see left-hand side with a funny arrow and then a right-hand side. The bolding is just for my presentation here to draw your attention to stuff. It's not actually anything to do with the language at all. So let's look at the left-hand side, and we'll go through it position by position. The first position of the left-hand side has a 0 in it. What's going to happen when you try to apply this rule to a state is that the left-hand side will be unified with the state on a position-by-position basis. And so when you try to unify a constant with something in the state, it has to be exactly the same constant. So that's actually a precondition that says the first state variable must be equal to 0. So that's how you read that, the 0 there. After that, you've got 3 variable symbols, a, b, and x. And these are not constraining in any way. So there's no more preconditions. The only precondition in this rule is that the first position must be a 0. But what happens when you do the unification is that there's a binding, just like always in unification, there's a binding to those variable names. And so if you had, for example, if you had the state that was 0, 1, 2, 3, then when you bound it to that left-hand side, the 0 would match, a would be bound to 1, b would be bound to 2, and x would be bound to 3. So you just take whatever's in the state and you bind it to those variable symbols. And this is the extra power that you get. That it's not first order by any stretch of the imagination here. This is completely simple to do. It's position by position, and either you have a constraint or you just bind to the variable. But that's what happens on the left-hand side. And then on the right-hand side, you can see it's a vector of length 4, just like it's supposed to be. And it's a mixture of constants and variable symbols. And this is now specifying the effects of this operator, assuming that it was able to apply to the state. In other words, it could unify with the state, the left-hand side. And so you can see the first position is a constant. And now this, of course, specifies that that constant will be in the child. The child will have a first position equal to 0. And then you've got 3 variable symbols. And they picked up bindings from the left-hand side. And so they are not really variables anymore. They're constants now in this binding. And so the bindings just get filled in there in that particular order. And so that's the whole semantics of the rules. There's one little twist that's coming up in another example soon. But you can see the net effect of this rule is to test if the first position is 0. And if it is, it swaps the middle 2 positions. Okay, because A was bound to what was in the second position, but it now gets inserted into the third position, and B was bound to what's in the third position, and it gets inserted into the second position in the child. So this is a swapping rule, yeah?
Do we assume that variables... Sorry. Yes. Hi. So do we assume that the variables have the same domains? Because if you're talking about 0 and 1 and swapping values, the values must be valid, right?
Yeah, so this rule would be rejected by my compiler. I don't know what Florian would do with it, but he doesn't deal with the PSVN language, so he wouldn't do anything with it. This rule would be rejected by the compiler if the types of those 2 positions were not identical. And so the type checking is done at compile time.
Okay.
Whoop, don't want to get a hit here. So this rule looks a lot like the last one, but it has an interesting twist to it because the same variable symbol occurs twice in the left-hand side. So when you go to unify this with a state, the first position is no longer constrained. It just gets bound to X. The second position gets bound to A, no constraint. But now when you come to the third position, A has already been bound to whatever was in the second position. And that binding is now in force. And so this is actually an equality test. This is testing that the second and third positions are equal. And if the state has the same constant in both of those positions, then the left-hand side will match. And if it doesn't, then it will fail to match. And so those are the 2 things that 2 kind of preconditions you have in PSVN are testing equality against a constant, just like you have in SAS+, and testing equality of 2 variables, which you don't have. Meanwhile, of course, things get bound just like they did before, and you can then use them on the right-hand side. And there's nothing really interesting about the right-hand side here. The last three positions are just left the way they were. The only thing that's slightly interesting about the right-hand side is that it actually makes a copy of B. So B was the fourth constant in the state, and it now gets copied. It stays in the fourth position, but a copy of it gets put into the first position too. So that is the quality test that you have. And the other thing that I thought you might ask me this question before I even got this far, but you guys are being polite, is what happens if you have a variable on the right-hand side that doesn't occur on the left-hand side? Now you might consider this to be, maybe this should be illegal, but there's a good reason why it's not. So that's an unbound variable, okay? When you match the left-hand side, then the first and fourth positions have an equality test, the second and third positions have an equality test, and A and B get bound, but X is nowhere to be seen. The meaning of this in PSVN is that you get not one child when you apply this to a state, but you get a whole set of children. And whatever the domain of that position is, you get it instantiated in all possible ways. So if that was a binary domain, you'd get 2 children. If it was a 10-valued domain, you'd get 10 children by applying this one rule to the one thing. If you had an X and a Y, you get all possible values of X and all possible values of Y's in all possible combinations. So you can get quite a large blow up going on here if you have a lot of unbound variables on the right-hand side that are different. If you had 2 X's, then you would get all the possible values of X in both places. They would always be equal. Like it's saying on the right-hand side, I don't know what the value is going to be, but I know they're going to be equal. And so it instantiates them in all possible ways. So the same rules about multiple occurrences occur there. Yeah, Florian?
Is this considered the same rule or for the successor generation, or are the different instantiation of X considered different rules?
Yeah, so the exact implementation isn't totally nailed down. The way we do it right now is that we actually generate internally, we generate multiple copies of this rule, one for every one. And I'm not sure this is the actually best way to do it from an efficiency point of view, but it's the way it's implemented right now. And so then when you ask for and each one of those then gets a separate rule ID. So in the API, there's a way of finding out how many rules there are. And let's suppose you just had that one rule. This constant would not be equal to 1, okay? It would say, if that was a binary domain, it would say there are 2 rules. Even though you only put in 1, because it grounds them out at compile time and counts how many there are, it tells you how many of there are. And so then each one of those has a separate rule ID. So when you're iterating through the children, you would forget the first version of this, and then you'd get the second version of this, et cetera, et cetera, et cetera. They all happen to have the same, oh, I haven't got the labels yet. So I'll continue the answer in a second. But there was another question? Yeah. Jordan, yeah?
So I was going to ask, is it just one or all? You can't apply a filter to that binding, for example, if you really wanted to be clever?
No, it's a kind of extension you could imagine to the language, but it's not there right now. Yeah. Chris? Oh, yeah.
What happens if you stick a Y, so there'd be 2 unbound variables on the right side? We'll give you the direct product of the 2.
Yeah, it gives you the product. Yeah. Because X and Y are not constrained to be equal, so you get all the combinations. Good. All right, so this is the hardest part of the whole language, by the way. In fact, this is almost all the language. There's a few things you can do. You can put a label on each operator, and so that's just keyword label followed by any old token. And this is really only useful for you to debug your code or to print out a solution path or something like that. It actually has no meaning at all. It just gets dragged around with the operator wherever it goes. So, anyway, it's there for you if you want to use it. Every label, if you don't give a label to a rule, it's given a label of the form rule 01 or something like that. You can have a cost associated with operators, non-negative integer, zeros allowed, and just like any kind of little programming languages, you can put comments anywhere. We use the % to start a comment, and it doesn't have to go on an operator. It can go anywhere, anytime. And just like with most programming languages, when you see that symbol, the rest of the line is ignored. We also allow the sharp symbol as well, so we have 2 comment symbols. I have no idea why. So Neil Burch did most of the implementation of this, and he's a fantastic guy. Why he put in 2 comment symbols, I have no idea. But anyway, there are 2 right now. So I just want to illustrate one last feature of the language, and I'm going to do that by talking about this little puzzle called the arrow puzzle. So this is the 4-arrow puzzle, because you can see there's 4 yellow arrows. An arrow can either point up or point down. So the natural way to represent this is with Boolean variables. And then the operators are shown as little buttons between adjacent arrows, because that's what they do. So operator M1 there will reverse the polarity of the two arrows that are adjacent to it. And so it reverses A1 and A2. So if you apply operator M1 to this state, then it would change A1 and A2 so that A1 was pointing down and A2 was pointing up. So it simultaneously flips two adjacent ones. It's not a very exciting puzzle, but it has some interesting properties, so I like to use it in my experiments. Here's how it would be encoded. Here's how M1 would be encoded. So there's no built-in function called flip an arrow or anything like that. And so you have to actually spell it out exactly the way you would in SAS+. If these two arrows are 0, then they both become 1. If they're both 1, they both become 0. So you have to list them all out there. So there's, what I really want to point out in this example is the A's and the B's. Imagine you had lots of arrows. Each one only affects two variables, and yet you've got all these variables sitting there, and it's actually very hard for a human to see what's going on. What is this rule actually doing? Because your eye is just drawn to all of those nice letters, and there's no bolding in the language, and so you don't get to see the zeros and the ones. So we introduced this is the only concession to human readability, is an anonymous variable, like you have in Prolog, anonymous variables. So the dash is an anonymous variable, and on the left-hand side, it means I don't need to know about this position in the state. And on the right-hand side, it means the value in this position is not changing. Okay, so they don't have to, in this particular example, they line up. The dashes on the right and the dashes on the left are the same, but they actually can be in arbitrary locations. And so, so that's a way of the human eye being now drawn that can see the fact that these operators are only dealing with the first two positions. So that's just a, yep.
Having XY and then XY on the other side is equivalent, right?
Yeah, these two rules are equivalent here. It's just strictly cosmetic. In fact, inside the compiler, the very first thing that happens is the dash gets turned into this. Jordan?
Thank you. Me too. So you love large problems, and
Yeah.
I don't want to write down the 50 arrow problem in
Yeah.
this formalism. How do you get around that?
That's what PSVN generators are. So what I do, and this is actually tutorial exercise 1A, okay, so is I write code that generates this. And I don't have a formal language for that. So this is where PDDL and I really separate company is if all you're doing is using PDDL to generate SAS+, then why not just write a SAS+ generator in your favorite language with the flexibility of a full programming language rather than being constrained to a formalism. So that's the message about PSVN generators. So it's a good point to ask it, but we'll get back to that later. And exactly the comment you make is made in tutorial number 1, saying, why are we doing this by hand? Why don't we just write programs that do this? And that's what we do. Okay, so that's the whole language. There's a tiny little extra bits and pieces here and there, but that's actually the whole language you now know about the PSVN language. Like any constrained language, it's good for some things and it's not so good for other things. So, in some sense, I don't need you telling me what it's not good for because I've probably faced that already myself. But I just want to tell you something that it is good for, and there's domains. If they have these 3 properties that I'm about to show you, then you should probably think seriously about using a finite domain representation that's got sort of swapping like actions like this one does. So first of all, if you have a fixed finite set of things that are moving around a fixed finite set of locations, that's the first property the domain should have. And of course, one might think I'm talking about the sliding tile puzzle here, but I'm actually talking about the logistics domain. Any of these domains where boxes and trucks and airplanes are just kind of shifting around on a graph, multi-agent pathfinding. But the second property, that's not sufficient by itself. The second property is that the movement of things among locations is determined by types. And I'm not using the word type here in any special technical sense. I'm using the ordinary English word here. In logistics domain, you've got airplanes, and they can't go everywhere, right? Airplanes can only go to airports. They can circulate among the airports, but they can't go to the places where the boxes, the warehouses where the boxes are stored, and so on. And so you can have thousands and thousands of airplanes, but their movement is dictated by the type and not by the individual identity of the airplane. In some cases, of course, there's a very special airplane that can land on short runways or something like that, and so you might have more than one type. And finally, of course, the type business wouldn't make any sense if everybody was a different type. So the whole idea here is that you will have a small number of operators if you have a small number of types of things that dictate movement. So that if you have these 3 properties, and it turns out these are pretty common in a lot of the domains, I think in the planning literature you'll find that they have these properties. Here's a laundry list starting with the heuristic search type spaces and moving more onto the planning type spaces domains in the end there. And a particularly useful thing for PSVN as opposed to SAS Plus is if lots of things are moving simultaneously. So if one thing's moving at a time, then you don't end up really, the grounding is still an issue, but it's maybe not a big issue. But so the example that I want to bring to your attention is Scanalyzer, which was introduced to the planning community IPC 2008. And in case this is just an abstract name to you and you didn't know what it was, it's actually, this is a picture of the automated greenhouse that Scanalyzer is based on. Okay, so you've got plants that are in these containers called cars, and then there's a whole crazy sequence of moving tracks that the things could be shifted around in the warehouse. And the idea is that different parts of the warehouse might have different exposures to light and humidity and moisture and stuff like that, and you want the plants to be circulated around, and the connectivity is obviously limited by the physical conveyor belts that you have there. So if you go to the PDDL, here's the action schema for the main operator. There's a couple of other little ones, but this is the main operator. It's called rotate 4. And let's just see what you got here. So remember locations, things, etc. So the locations here are variables S1 to S4. The things that are currently sitting in those locations are C1 to C4. And this is a static predicate that indicates that S1, S2, S3, and S4, these 4 locations are connected in the physical plant by some kind of conveyor belt. Okay, so that tells you the connectivity of the instance, and that tells you whether or not you can actually do a cyclic rotation. So this is supposed to do a cyclic rotation. Those of you who are super familiar with PDDL can probably instantly see that from the PDDL, but I like pictures, so I'm going to draw you a picture in case you didn't immediately see that. So S1, S2, S3, S4 are the locations, C1, C2, C3, 4 are what are currently sitting in them. So this would be like the precondition of the operator. And then the postcondition just does a cyclic shift. I've used colors so that you can easily see the green thing was in position, it was in S2, it now goes to S1, orange thing, blue thing. Everybody's moving left, and the leftmost guy comes around to the right. And so that's what cycle 4 does. But what I want to point out, and this is sort of pointing out the difference between SAS Plus and PSVN, that's why I'm going through this example. So if you look at Scanalyzer instant number 28 in the IPC, there are 12 locations in total in this instance, and there's 12 things. And always one thing is in one place. So it's a one-to-one mapping between locations and things. And it turns out the connectivity constraints are pretty strong in this particular instance. Even though there's 12 to the 4th conceivable different S1, S2, S3, S4, there's 12 to the 4th of those. There's only actually 9 that are allowed because of the connectivity of the conveyor belts. So now the question is, this is the big question for you, is how many SAS Plus rules are generated in this domain? Okay, and so this is where you get to see some of the power of these little PSVN ideas. Okay, so how many rules are there when you run this through, when you ground this out? If you did a naive grounding, there'd be 12 choices for each one of the SIs and 12 choices for each one of the CJs, and so you'd have 12 to the 4th squared, which is 500 million. So luckily for all of us in the room, Fast Downward Translator is a lot smarter than that, and it actually sees that there's only 9 possibilities for the S's, but it doesn't quite sort out the fact that there's not so many possibilities for the C's, and it grounds out all the C's basically in all possible ways. But it gets it down from 500 million to 186,000. So if you look in the SAS Plus file, then you'll see 186,000 grounded operators. If you look in the PSVN file, you'll find 9. Because it doesn't do any grounding. It can actually do the binding and then do the shifting in a rule that looks just like this. Okay, there's S1 is the first position, S2 is the second position, and then S3 and S4 down are where the C3, C4 are. So C3, these are now variable symbols in PSVN, and we don't care about the other positions. They're not involved in the rotation. And then you can see that the rotation is just put down almost exactly the way I did in the pictures. The one that was in S1 goes to S2 goes to S1, et cetera. So this is actually, you just have 9 of these based on the connectivity. They would all look pretty much the same. And so you can see that this is going to make everybody's processing faster. Instead of having to weed through 186,000 fully grounded things that each got 4 preconditions in order to decide which rules apply to which state, this one has no preconditions, so it always applies to the state. And so it instantly, there's no testing to be done. There's only 9 of them, so they're very easy to sort through. So this is just trying to be a kind of an impactful example of how these simple swapping ideas do come up in planning competitions and can save you a massive amount of space and time. Okay, so we talked about the API, we talked about the language, now we're going to talk about the glue that holds them together. And if there's a take-home, well, anyway, we'll get to the end when we get to the end here. So first of all, I just want to really emphasize the fact that this is a bit of a different approach than what you might be used to. So first of all, there's your C or C++ planner code written using the API. So that's now written and you've got it all finalized. And somebody comes along and wants to apply your planner to their state space. And they've defined their state space in PSVN. So what do they do? So a common approach these days is for the planning code to actually read in the state space definition at what I would call runtime and do whatever processing it's going to do and then start the search all as part of one big run. But in the compilation approach, you actually separate those two things completely. And so there's my software in the middle, this PSVN to C compiler that takes a state space definition in PSVN and produces C code that implements the API specifically for that state space. So it's not a generic implementation of the API. It's completely specific to that state space. It has not looked yet at your planner code. In fact, this is a neutral. You could change your planner code and you wouldn't have to redo this step. This is just creating an API implementation of a state space. So now what have you got? Now you've got C code and you've got C code. So guess what? The C compiler is naturally the thing to bring two pieces of seed code together into the same place. And so you have to at some point compile your code anyway. So when you compile your code, you just include the API code that was generated there. And now you've got your planner code specialized to search in this space. And so that's the two-step process in what I call the compilation approach. Is you first turn the PSVN definition into some programming language. In our case, we chose C. And then you compile that together with the search code, planning code in order to get this specialized planner out here. So, again, my background is that I tended to build pattern databases and do pre-processing that was then going to be reused many times. And so the compilation approach is really ideal if you're in that setting where the state space isn't changing, but all that's changing maybe is the start state. You want to run your experiment on 1,000 different start states of the same thing. You don't want to have to do that compilation 1,000 times, so why not just do it once? So that's the ideal setting for the compilation approach. It's the setting that I came from. And if you're just solving a single instance, as in the planning competition, it's not obvious if this is the right way to do things, but it's yet again, it's like food for thought. Like one of the things you'll find in this presentation is that, pardon? It can be slow, let me put it that way, okay? I don't want to say that it's always slow. It depends an awful lot on how many rules you have. So for example, that Scanalyzer example we just saw, if you put the PSVN version into the compiler, it'll be instantaneous. Okay. And so will the C compilation, assuming your search code isn't a problem for the C compiler. If you take the 128,000 rules or whatever it was that in SoCS Plus that are hopefully grounded and you put it into the compiler, have a coffee, don't expect that to be
I was just thinking if you're on like half an hour solving time, and you need to do that compilation.
Yeah, so that's why I say that the fact is when you have 128,000 rules, then it's just going to slow you down. I wonder if some of these ones that aren't being solved by some of the best planners today are actually running into the problem that they're just gigantic, and so even reading them in takes 20 minutes. Well, that's why I chose Scanalyzer here, because I have a complete list of the sizes of these things when they're converted to PSVN, and some of them are, a couple of gigabytes. Pat?
Taking the chance of annoying you. So do you have either a PDDL to PSVN or a SAS to PSVN such that you can go from PDDL to SAS to PSVN? Yes, that's actually in the bonus material. The reason it's so big is because there's a large sample of the IPC domains have been translated to PSVN using our tool, and the tool itself is also in the PSVN, is in the bonus material. Okay, and so if there's new domains, like this year, there'll be new domains that I don't know about. Right, so you could run it in the competition, which was my question, right? Because you could generate SAS and then change the SAS into PSVN and then run a... Yeah, except remember, PSVN isn't a search algorithm, so it itself would never be in the competition. It might just be a piece of somebody else's entry in the competition. Right. So I'm not the first one to take this, just in case you're wondering. There has been at least one attempt
in the planning world to take the compilation approach, and that was functional strips. There may be others too. That's just the one I'm aware of. So what's the value added by a compiler? Well, the first few bullet points here are really just value that could be added by any kind of preprocessing step that reasons about the state space. And so the fast downward translator is an example. And so you get a bunch of rules in some arbitrary order. They have overlapping precondition tests. And so one thing you want to do is to optimize the order to minimize the number of times the same test is done. And in our particular case, we try to optimize the order in which the tests are done in order to most quickly find the first rule that applies to a given state. So if you're running something like A star where you're going to generate all the children, it doesn't really matter which one, how fast you get the first one. But this was designed for depth first searches as well as breadth first searches. And so in depth first searches, you often don't generate all the children. Often you generate one child and then you find a solution or you give up or something. And so that's why we optimized for that particular criteria. And I put optimize in quotes because obviously we don't optimize anything, but we try. Automatic move pruning. If you don't know about move pruning, it's an extremely powerful analysis that we do at compile time that can speed up depth first search by orders of magnitude. So if you're doing depth first style searches like IDA star, then you definitely would like to use the move pruning that we've got in the compiler. It automatically infers operator inverses. This came up at a question this morning. I don't know how many of you were at Ariel and Nathan's thing this morning, but somebody was talking about backwards search and don't you need to have invertible operators? And the answer is the operators themselves could be directed as long as you can infer backwards through them. And just like you do regression planning in directed spaces, this is effectively saying that you can do regression style reasoning, but it actually generates the operators. It doesn't do that reasoning at runtime. At compile time, it actually generates a whole new set of rules if you turn on the option for going backwards. The other thing they can do, which may be a little bit harder to do at runtime, but since we're operating at compile time, we can do this, is the number of bits that are used to represent a state is something that we try to minimize. So we look at how many bits are needed for each one of those domains, and we kind of add them all up, and that's how many bits we try to allocate to the vector. And of course, there's no interpretation going on here at all. We generate highly efficient C code. There's a ton of inlining that gets done by us, and then probably the C compiler does a whole lot more that we don't know about. And of course, it's all subject to the optimization power of a C compiler. So I think we get pretty efficient code coming out of this. So that's the end of, where are we sitting here? Oh yeah, good. So that's the end of the talk about remember there's 4 parts here. Now we're into the software suite. And all I'm gonna do here is just briefly tell you what you'll find mostly in the bonus material. And I'm not gonna spend a lot of time talking about this because I wanna get to the hands-on part. So the first thing is that there's search code of various kinds. The tutorial lessons, which you're going to work through at your own pace and at your own interest level, contain many of the basic algorithms. There's a breadth first search, depth first iterative deepening, Dijkstra's algorithm, IDA star are all in there. As I said, A star is not quite in there, but Dijkstra's algorithm actually uses the priority queue implementation for A star. And so you have the priority queue is all set up for A star. All I have to do is import and put in a heuristic. So anyway, we didn't actually get that far. That's a good exercise for you. And code for generating and using pattern databases is all part of the tutorial lessons. So remember when I distributed the material, and for those of you who came in a little bit late, there's actually USB sticks floating around that have got, and they've got 2 parts. There's the core part that was in red on the first slide, which got a name PSVN something, and then there was the bonus material. And so all of the stuff in the tutorial lessons that I mentioned there is all in the core material. And then the bonus material contains the one search algorithm it has right now is a greedy best first search with the FF heuristic. And I want to make 2 thank yous. One is thank you for the fast downward people for writing such beautifully factored code that we could take the implementation of the FF heuristic completely, just swipe it out of the fast downward implementation. And thanks to my student Fancy, who actually did the work of putting the pieces together, putting the fast downward SAS plus based FF code together with the PSVN stuff that we're doing. But there's search-related code that's kind of interesting. If you don't know about stratified search, it's actually a pretty powerful method for doing many kinds of search-related activities. Levi Lellis was my PhD student, and he applied this idea of stratified search to a whole bunch of different things. The only thing he actually wrote in PSVN was this one that's actually called stratified search, and it is for predicting how many nodes IDA star will expand for a given heuristic and cost bound. And so if you want to have a prediction algorithm to say, is IDA star a good choice on this problem, then you can just run stratified search on it, and it rather quickly tells you how many nodes are likely to be expanded. There's also data structures. State map is our name for a generic hash map which we use for pattern databases primarily, but it really just takes a state, maps it to some kind of index, and stores an integer beside it. So that's a state map. And then there's the double bucket priority queue that I mentioned. You'll see that when you work with Dijkstra's algorithm, but it's actually intended for A star. This is the code that Pat asked me about. There's a thing called SAS to PSVN, which translates the output from fast downwards translator. So it's not any old SAS plus, it's very specifically the output of fast downwards translator to PSVN. Unfortunately, there's no AI inside this piece of code. It just literally transforms the syntax. It doesn't try to reverse engineer the bounding of the variables or anything. If there's a constant, it gets translated to a constant. So the fully grounded SAS plus gets translated to fully grounded PSVN. If somebody wants to take on the AI project of trying to figure out how to infer unbound or the insert variable symbols, then that would be a nice research project. Yes, that would be if somebody was going to do this. Yeah, I don't know that anything with PDDL is easy, but the advantage, I mean, it's kind of a tough choice because the translator does more than translate. The translate does a lot of analysis at the same time that it's doing the translation. And so you would lose all the stuff that the fast downward translator is actually doing.
I agree.
Yeah, but in programs like Scanalyzer, you want to take advantage. In programs like Scanalyzer, you want to take advantage of the PSVN power.
Yeah.
So if you take SAS plus output
Yeah.
from Scanalyzer and bring it to PSVN, you don't get anything.
And the only reason I do this is so that, for the reason that Pat said originally, is this way if you want to run on exactly the same instances that fast downward is dealing with, then this is what you want.
Yeah.
It's not what you really want, but if you want to do a direct comparison of apples to apples on the Scanalyzer domain against fast downward or anybody else who uses the fast downward framework, then this was something that was easy to do, and I thought it would be convenient for people.
Very good.
Yeah.
Yeah, I definitely recommend writing a PDDL to PSVN translator. I mean, I've written PDDL to PDDL translators.
Yeah, I know you're
and
such
they
an
are
expert on it, Pat. I'm looking at you.
difficult.
And the only other thing I'll mention is that it doesn't handle conditional effects, which aren't actually originally in SAS Plus, but the fast downward version of SAS Plus has got conditional effects in it, so those ones we just abort on those ones. This idea of PSVN generators, I told you I would, in the take-home message, that I thought this was a good idea. Jordan asked me a question, which then made me reveal my hand a little early. But let me just go through it very systematically here to tell you what these things are. So almost all problem domains have got usually lots of parameters, but at least one parameter. And so in the Towers of Hanoi, just to pick an example, the number of disks is the classical parameter for this thing. You usually have 3 pegs, and then the number of disks is a parameter that varies. But of course, as you know, some of us anyway have looked at multi-peg or more than 3 peg problems, and so really the number of pegs is a parameter as well. And if you use your imagination, you could probably think of, or if you chose a different domain, you could probably think of hundreds of, or many other parameters. So what a PSVN generator is just simply a piece of code that you have written for a parameterized problem domain like this, which you give it parameter values and it spits out the PSVN for that particular instance of the family of parameterized problems that you're talking about. And so in our particular case, we have a PSVN generator for Towers of Hanoi, which has these 2 parameters. You say, I've got 10 disks and 4 pegs, and it actually then produces the PSVN that you would then put into the compiler, et cetera, et cetera, et cetera.
So it's very much like a paddle generator.
Like a?
Paddle generator. Paddle generator.
Oh, a PDDL generator.
Yes.
Okay, yeah.
Sorry.
Yes, yeah, no, I hadn't actually seen PDDL generator, so I'm learning something here today. It's sort of the obvious thing to do, and so I just went directly to doing this. So in some ways, it's what Fast Downward does this, and people do this with PDDL by itself with the static predicates, like in the connectivity of Scanalyzer. I said there was a static predicate that said, these things are connected by conveyor belts. And in some sense, that's a parameterized family. I mean, obviously, Scanalyzer is a hugely parameterized family. And a lot of it's being achieved with the PDDL static predicates, and when Fast Downward translates it, it actually gets rid of the static predicates by doing exactly what these generators do. It makes a special version of the SAS Plus for this particular pattern of connectivity in Scanalyzer, for example. One of the things I like about this is that I have 2 research directions that I'm very interested in. One is really seriously looking at the performance of our algorithms when operators have a variety of costs, and not just all costing one. So I call these things cost models. The cost model is, what is your model of how operator costs are distributed? Are they all equal to 1? Are they random numbers between 1 and 10? Is it the case that the disks in the towers of Hanoi, that the heavy ones are more costly to move than the light ones? And so you can imagine many different cost models. And so the nice thing about just writing code in your own language is you can actually build in cost models as well. And so if you look at the towers of Hanoi generator, in addition to having those 2 parameters, it's got parameters that dictate which cost model you want to use and whatever parameters like random number seeds or whatever for those cost models. The other thing that Pat and I have looked at, and I've always been interested in this, is how do different encodings of the same problem domain affect our algorithms in terms of their speed and effectiveness and so on. And so again, if you have a problem generator for the towers of Hanoi, you can switch between different encodings. You just say, I want this encoding or I want that encoding. And of course, somebody has to actually write the program to do this, but at least it's all sitting there. And so in the towers of Hanoi, there's 2 different cost models. There's obviously these 2 parameters. And there's 2 different encodings, one that's specialized for the 3-peg problem and one that's generic for any number of pegs. And so the generators can be much more than just, oh, here's the number of pegs and the number of disks. They can have a very rich space of things that they can generate. So I think they're a good idea. So now I'm finished my introduction here. I just want to go back to the main points, just to remind you that PSVN is not one thing. It's an umbrella set of letters for 4 different things. There's a language, the API, compiler that glues those 2 things together, and then a growing suite of software that uses the API or in some other way supports the use of PSVN. Take-home messages. There is a sweet spot between fully grounded SAS Plus and PDDL. I think the PSVN language is a proof by example that such things exist. And like I said, even if there's some details you don't like, the take-home message really is that there is this sweet spot, and we should be working in that area, I think, not in the other 2. Having a state space API, this is the advantage of just having an API, so I won't repeat this. I think all of you heard this at the beginning, that it just facilitates software reuse, and it's not hard to do, at least for this particular API. I said I like the generators better than the using static predicates in PDDL, but there is one exception to that, and that is if you have a system that actually reasons about the PDDL. Okay, so it's not just translating it blindly into a grounded language, but it's actually looking at the PDDL and saying, like for example, the fast downward does the invariant analysis that ultimately generates mutex stuff. It does that by reasoning about the ungrounded PDDL. If you're going to reason about a language, then it better be a declarative language with a pretty decent semantics. And so you would never use a generator. If you were going to reason about the PDDL, then you should stick with the PDDL. If you're not reasoning about it, if you're just pumping it through and turning it into something grounded and then reasoning about the grounded thing, then maybe you should just use a generator and be done with it. So where are we now? So now I'm going to take a, sorry, Jordan, yeah?
So you've made some hay about efficiency a couple of times, and I mean, obviously, like if you encode a grid finding problem, Nathan's still probably going to wipe the floor with you. If you run on the 15 puzzle, Rich's code is probably faster.
I doubt
it. You don't have a sense? Okay.
Yeah, so there's some, we tried doing a comparative experiment, this is maybe 2 or 3 years ago now, and the trouble is it is very hard to make an apples to apples comparison. Is the human written code is always, in addition to generating successors, they're keeping track of some side variables because they're going to need those for doing something else. But of course, the PSVN is only about generating the successors. And so we did have some timing studies, and we actually submitted a paper to SoCS many years ago that got rejected. The timing studies were always a bit iffy. What I remember of them is that, so Neil Burch, remember, is the guy who wrote this. He also is an extremely good programmer. And we had some of the code that he written, what was domain specific, and PSVN was outdoing Neil. Okay, and so I would very much like to take on the 15 puzzle, because I know Ethan did that big study on the 15 puzzle, and I just wanted to get machines at New Hampshire, like the same machine, and run the PSVN part. The part that's a bit tricky is the incremental computation of the Manhattan distance, because for us, we don't expose the internals of the state to the user, right? It's kind of that's the API says there is a state type, and as far as you know, a state is just a number between 1 and 100, right? And so, so there's a little bit of a problem doing the incremental calculation. There are a couple of ways around that, but none of them is beautiful. And so the Manhattan distance part is something that is sort of a loss because we have an opaque state. we have translation to a non-opaque state type, but that's a slow process, right? And so you don't really want to do that. So I think there are probably ways of doing Manhattan distance fairly quickly, but if you were to just take that out and use a pattern database, say, then you wouldn't be looking at the state. We have abstraction functions and stuff that do all that stuff in another part of the API that I didn't show you here. And so I think that the basic the basic state generation, it wouldn't surprise me if it was as fast. Because a lot of the things, you haven't seen that talk. Actually, I'll show you a talk afterwards. So Ethan Burns and others at the University of New Hampshire wrote a paper about high-performance implementation of IDA star, and virtually everything that they do there to get their performance wins, we can do. And so I don't think there would be any code differences except for the incremental Manhattan distance. So at this point, this is where you're really going to start needing that thing in red, because that's where the tutorial lessons are, that's where the manuals are, that's where all of the code that you really need is. So there have been, I've got a couple of others here, but there's plenty out there. If you didn't already get yourself... Anyway, so there's USB sticks out there, so if you haven't already loaded that stuff, then just there should be a few sparkled around here and try and get that stuff. Because what's going to happen now is that I've got a little bit more wrap-up to do, but I'm basically going to walk you through the first tutorial. It's supposed to be self-guided, but I thought while I'm here, you're here, I might as well take you through the first tutorial, just so you get used to their structure. And then after that, that's when when is the coffee break, by the way? Must be coming up soon. Is it 3?
10 past 3.
10 past 3? Okay, good. We'll be ready for it then. So anyway, so I've got a little bit more wrap-up to do, and then I'll take you through lesson number 1, and then you'll definitely be completely on your own at that point, and I'll just be here as a resource person. So the end of the wrap-up is to just tell you what's in the bonus material. So this is the 700 megabytes, which is mostly just SAS plus stuff converted to PSVN. So if you look in the main directory of the bonus material, you'll see, I think it's 3 files that start code dash and then something. And so this is the bonus software that you get. This is the SS software, the SAS to PSVN, and the GBFS with the FF heuristic. Those are the 3 things that would have that name. Then there's a directory called documents, and that's got these slides on them. It's got published papers about move pruning, if you want to know more about move pruning. It's got the original 1999 PSVN technical report for historians in the audience. Actually, it's an interesting read. There's some good stuff in there. And then the other 699 megabytes are the selected IPC problems that have been converted using the code that I was talking about earlier. And so the reason it's selected problems is because this vector notation is actually quite bulky. I'm now thinking maybe I shouldn't have used the vector notation as the external notation, even though we use it internally. Probably should have a more compact external representation. And so you can imagine there's like millions of dashes in some of these problems, and they just take up 2 bytes. The blank and the dash take up 2 bytes each. And so there's I think one of them is almost a gigabyte by itself. So that one's not in the distribution. That one you'll have to do yourself. I can't think of a way of distributing all of them. So this tends to be the domains that were all reasonably small once you converted them. Okay, so that's the bonus material. That's just an overview of what's in the bonus material. Now let's look at the core material. This is in the other directory, this one here, the red one, so to speak. This one you should all have. So there's directories called documents, lesson 01, lesson 05, problem domains, test. And so what's in each one of those things? So documents, you'll spend a fair bit of time in the documents because that's where all the manuals are. The PSVN manual is the manual about the language, but it also has all the examples of the API in the PSVN manual. Then there's the API manual itself with the appendix for PSVN to C, telling you exactly what functions and so on are available and how PSVN implements them. And then there's the software suite manual, which has documentation on those 3 things called code-XXX. The tutorial lessons are where you'll spend most of your time. You'll go through them, not exactly in the order listed here. I'll get to that on the next slide or 2. But anyway, you can go through them in any order you like, really. Going through them in numerical order makes sense, but in the interest of time, I'm going to suggest a few shortcuts. Problem domains is a directory where you will find the problem generators. And I'll talk a little bit more about what the structure of that directory is in a second. And then there's a directory called test, which if you follow my suggested order, you won't get to today. And I realize there's a little bit of a problem in that directory because in the subdirectories here, you will find executable code. And of course, it was compiled on my machine. There's no chance that this executable code will run on your machine. You'll have to recompile it. But I left it there. I put it there for a good reason so that you knew what had to be in that directory. Okay, so there's a PSVN file and a C file. Those ones can stay, but then there's the compiled file. And I distributed it with the compilations in there, the executables in there. They won't execute on your machine. It would be a miracle. Okay, so those are the directories that are at the top level of this directory. And then also in the top level, you'll see a make file and all the code needed for the compiler, PSVN to C. So hopefully everybody is seeing that. No surprises. Everybody's good? Okay. If you go into the documents, well, you don't have to go into the documents. This is just a brief overview of what's in the manual. I already said most of this. It is really a complete description of the PSVN language. There's a few things I didn't tell you about that are they're not exactly minor details, but you can read about them. Snippets of code illustrating how to use the API. Overviews of move pruning and abstraction, if you're not too familiar with those things. And then the tutorial lessons themselves, so the written lesson is actually at the end of the manual. So that's where you'll find the tutorial lessons. I thought I'd put them there rather than having a separate document because you're constantly flipping back and forth, so you might as well just have them together. In problem domains, this is where the generators are. And I don't even remember how many there are. I think there's about 8 that are in there. And each one of these, so there's a directory for the Towers of Hanoi, there's a directory for the arrow puzzle, etc. And exactly what's in each of those directories depends to some degree on the domain. There will always be the code itself for generating the PSVN. This is the generator, the code generator itself. And then there'll be a README file for sure that tells you what the code does, what the domain is, what encodings and cost models are supported, et cetera, et cetera. So there'll be at least those 2 files, and if the auxiliary files are needed, then they'll be there too. Hopefully those are all self-explanatory. And this, as I mentioned when Jordan asked the question, problem generators is entirely the subject of tutorial lesson 1A. So once you've finished tutorial lesson number 1, then if you want to play around with generators, then you can go to 1A and ignore my instructions. I wasn't sure what to do about these things. So over the years, students and various people working with me have written generators that aren't quite the way I would really like them. Okay, so I put them in a special directory called to do, which is really my list of things to do, is to take these. They work perfectly well, but they don't have all the parameters that I want, and it's not really that they're badly documented even, it's just that I want to have more flexibility. Say, for example, in the sliding tile puzzle, they're inside to do, there's a sliding tile puzzle generator, but I want to be able to glue tiles in place, and I want to have the macro version of the sliding tile puzzle. If you don't know what these things are, it doesn't matter, but these are variations that I've worked on in the past, and the generator doesn't support them, so I just need to roll up my sleeves and spend a couple hours writing code so that I can take that generator and bring it up to snuff. But anyway, I thought at the end I would distribute them on a kind of an as-is basis, and if they don't do what you want them to do, then basically write your own. So that's, or start with those and fix them up. Okay, so now let's talk about the tutorial lessons, because that's what the rest of the time is going to be spent on. So there's lessons 1, 2, 3, 4, 5, and they all have a directory. You know, this is the directory for lesson 01 is right there. And these are really meant to be demos to teach you something specific. And so the make file that you will find in there is completely specific to that tutorial. You know, and when you go to tutorial 2, it doesn't even have the same stuff. You can't even redo, tutorial 1 with the make file that's in tutorial 2, or et cetera. I just wanted to keep everything as minimal as possible so you were totally focused on whatever the lesson was trying to talk about. And so anyway, that's what the make file does. But the topics of the tutorials are here. The first one, you definitely want to start with lesson number 1. Well, I'm going to take you through it. And then after number 1, you could go on and look at the generators. And after that, you could look at a whole search algorithm. Depth first iterative deepening is tutorial 2. Tutorial 3 is searching backwards. So you get to see the other half of the API, the backwards half of the API. Tutorial 4 is about testing search algorithms. That's just me trying to encourage people and give them tools so that they can actually properly test search algorithms in a fairly exhaustive way. And then this is the one you want to get to, is using abstraction to create a PDB, a pattern database, and use that pattern database in IDA star. So this is really getting you to the point where you can do serious heuristic search, and that's where you want to get to today. So as a consequence of the time being limited and me wanting you to get all the way to lesson 5, you can see I've cut a few things out here. So my recommendation is you go 1, 2, 3, and 5. and you skip over 1A, and you skip over 4. That's my recommendation for today, but you're grown-ups, you can do whatever you like. Okay, so let's actually do lesson number 1. And I'm going to roll up my sleeves now. That's where we're at. We're at the lesson number 1 thing. And I have got a Unix image running here somewhere. There it is. Oh, it timed me out or something. There we are. So this should look, aside from the prompt, this should look exactly like what you've got. This is the 2 things. You can see I just did an ls there. So in this directory, I've got the bonus material and I've got the PSVN. So you'll go into I call this the main directory, by the way. So this is the one that's got the documents, the lesson directories. Can everybody see that, or do I need to make it bigger? Is that okay? I can see it. Okay. Right, and then of course you can see the things called with PSVN. That's just the code that's needed for PSVN to see. So we want to go into lesson number 1 here. You'll find out how badly I type and let's see what's in there. Not much. Okay, you can see. Hopefully you're seeing exactly the same thing. If you're not seeing exactly the same thing, you have a problem. So there's a make file, there's a PSVN file, and there is search code, okay, which is not really search code. All it does is compute the successor of a function, of a state, okay, because I wanted to keep it, again, minimal code so you could see as much as possible. So now I'm going to flip back and forth. So now if you go to the actual back of the manual, okay, so open up the manual and go to page 10 of the manual, and I'm exposing all my secrets here. Then the next few slides I'm going to show you are literally copies of what you should have directly in front of you in the manual. Yes, psvnmanual.pdf. Yeah, and if you go to page 10, then this should be the first half of the first column, of the left column. Should be sitting there. And so all the tutorial lessons are really organized the same way. There's a little abstract at the beginning that tells you what the point of the lesson is. And then there's a series of things that you should do before starting this lesson. They almost always involve reading something, and in this particular, and they always end with changing to this directory, but in between there might be some other stuff to do. So this one says that we should stop right now and read up to section 3.1 in the PSVN manual. If you're doing this all by yourself at home without having sat through an hour of listening to me, then you would actually have to do that. But the good news is I've actually covered the essentials up to 3.1 already. So you don't actually have to do step 1 there. But for lesson number 3, which is on the agenda for today, you do need to read the section of the manual about the special symbol asterisk. Okay, so that is a special symbol that is especially important when you do backwards reasoning. And so that one you'll want to read before you do lesson number 3. Okay, log into a Unix system. Everybody's doing that. Change to the directory where we put all that PSVN stuff. Oh yeah, we have to be in that directory because none of you have an executable of the compiler yet. Okay, so let's go back to that directory there. And I took you into the lesson 1 too quickly, so I wasn't even following my own instructions. So we're back here in this main directory, and you can see there's all this PSVN stuff. And there's a make file. So it just make PSVN to C, and you may have a faster or a slower. Yeah, the top level directory. It's just one above the lesson directories. So anyway, there's me on my virtual machine. Hopefully everybody's faster than that. Did anybody get a problem? It all worked? Yay! Let's hear it for software reuse. Okay, back into, and then it says the last thing on the slide here is, where are we? Where did we get to? Okay, so we did that and it worked, and now we go to the directory. Okay, so I'd already went to the directory, you probably did too. So now I'm back to the manual again. Okay, you're looking at the directory, but maybe you can flip back and forth between these two things. So then the next thing in all of these lessons is it goes through the files one by one and tells you what each file is. And the particular order it goes through them in is just whatever makes sense. So this is just saying that there is some code written in C that reads a state from standard input and prints out the state's successors, et cetera, et cetera. So that's what, this is just telling you what that particular, it's not a search algorithm, but it's the hardcore, or it's the core of a search algorithm. And its purpose is to illustrate the API. Its purpose is not to do anything especially useful. Now, I don't want you to open that file right now because that's going to take too much time to scan through. But I just want to remind you of this slide that we saw, when we were talking about the API. Well, you will see virtually this identical code in in successor.c because it iterates through the children and prints them out is what it basically does. And so when you do look inside suc.c, you will see something that's almost identical to this. Plus, of course, other things to read in a state and to print out a state and other kinds of little things like that in the API. So obviously I can't stop you, but I'm going to keep talking about other things, so I recommend that you don't bury your head in successor.c just at this particular moment. Back to the manual. So the manual then is, like I said, it's going through the files in the directory one at a time. The next thing is PSVN for a little tiny sliding tile puzzle. This is the 1x3 sliding tile puzzle, and this is what the state space looks like. Oh, Nathan had the same problem. The colors aren't coming out. Anyway, there's a blank, and then there's two tiles numbered 1 and 2, and like always in a sliding tile puzzle, you can move the blank and exchange it with things. Notice this is not grounded. Like, this is literally what the PSVN looks like. If it says if the blank is here, then you can exchange it with whatever's to the left. This particular tiny little space, if you fully grounded it, well, funny things might happen. You might get that the 2 could be on the left or something. So anyway, this is literally what the PSVN operators look like. And this is and I've put random costs on those just so you can see how the costs work. They're not meaningful. They're just there so you can see how you put costs on operators. So this would be a good chance to look at your very first PSVN file. There'll be some bits in it that I haven't explained to you, but I think they'll be self-explanatory, and of course, if they're not, the manual will cover them. And so have a look at that file, and let me know if you have any questions about it. And in fact, I will do the same thing in my version. Now you see how old I am. I actually use VI.
I have a question.
Sure.
So the labels are non-unique. How does this work? So we have 2 labels left, 2 labels right. What do we do with the labels?
Nothing is done with the labels. The labels are just dragged around with the operator, and this is actually to illustrate the idea that in the sliding tile puzzle, which way did I do it here? In the sliding tile puzzle, regardless of where the blank is, things move either left or right, or in the two-dimensional ones, up or down. And so this is just saying, it's actually not saying which way the blank's moving, it's saying which way the other thing, the tile, is moving. So both those ones that are labeled left, a tile is moving to the left. And both those ones that are labeled right, a tile is moving to the right. So this was just to illustrate that you can label things any way you like. I mean, if you wanted to call them the blank in the left position moving to the right, I mean, you could give them as detailed names as you like. And obviously you can edit the file if you don't like those. Then you can change it right now if you like. But I just chose to do it that way just to illustrate the fact that if it makes sense for you, you can give operators the same label. It's got nothing to do with the identity of the operator. These will be numbered rules 1, 2, 3, and 4, or something like that internally.
So the labels are just for the humans.
Label is just for the humans. You can fetch them programmatically, and so you could build cost information into those things, and of course you can get the costs anyhow. But if, for example, somehow you were doing a wonky problem that had constrained resources, that comes out as a string, and you could put resource consumption information in there. Like PSVN itself doesn't have resource constrained problems, and it's not really a cost, but you could hide all sorts of stuff in that label and then parse it out yourself. So the labels can be, that's why we have them, is because they can actually be quite handy for all sorts of things. And one way we did tried to do the incremental Manhattan distance was using these labels in a certain way. But anyway, that's another story. So the labels are there. They can be actually reasonably powerful if you abuse them that way. Hopefully, any questions about the PSVN here? Sylvain? Oh, sorry, yes, sir?
Actually, no, it's fine. No. Two simple syntactic questions.
Yeah.
So first here, one of the comments is the pound sign. That's the other one, right?
Yes, yeah, I didn't actually say what it was. Yeah, right, yeah.
And then, is there any rules about the white space here, or?
No.
Okay, good.
No.
So for like domain, for example, it could be tile 3 B12 without a return line there.
Yeah. It's just the syntax is meant to be super simple. As there's just white space between tokens.
Great.
And that's it.
Great.
Yeah, and a new line is considered blank space. Is considered white space.
Right.
So that's why I split it. I mean, again, this is illustrating all those little syntactic things that I wouldn't want to take up time talking about. But those are good questions. Yeah,
good.
For sure.
So there is no initial state in this example?
There's no
initial state in this example?
Yeah, so this is another thing where, again, it's just my historical background. I tended to always run my experiments where I had many start states and one goal. And that's just the way my experiments were run. And so the language has kind of inherited my biases towards those things. So start states would get read in at runtime by the search algorithm. And when we convert, by the way, when we convert the the PDDL to PSVN, the start state is something we can't put in because there's no place for it. We put it in as a comment. So you'll actually see in the conversion, it says the start state, the standard start state is, and it says that in a comment so that you can just kind of grep out the start state and put it in a file yourself. And so we tried to make it, we would preserve the information, but it's just in a comment right now in the SAS Plus that we convert. Anything else? All right, you guys are masters of the PSVN. So what's next?
Sorry, there was one. I was just wondering, is the goal actually required? Because
Yes.
I mean, you could legitimately do it the other way around. For example, if you had one start state and wanted to find many goal states.
You know, this was something that I'm kind of still debating with myself. Putting the goal there in the file is actually inconvenient for many reasons. You have identified one of them. So it could happen sometime in the future that the requirement that there be a goal statement is relaxed, because almost all the heavy work that the compiler does is independent of the goal, and seems a waste if you were just to make a small change to the goal to have to go through that whole compilation stage again. And so so there's a few things that currently are done at compile time that I've got a list of things that are currently done at compile time that I'm going to make optional at runtime in future versions of this. And abstraction, for example, right now abstraction in the version you've got here in front of you has to be done at compile time. But having instance-specific abstraction is another thing that is an old hobby of mine. And so there is a version of PSVN that supports dynamically defined abstractions, and so that you can create your pattern databases on the fly or even just do hierarchical search. So anyway, that stuff is all coming imminently, but it's not quite ready right now for prime time. Yeah?
Out of curiosity, another of your hobbies, hierarchical IDA star. Have you tried to do that with this language?
Yeah, we have a complete implementation of hierarchical
is it any different
switchback. And what happens is, and this is something, I'm kind of wrestling with the exact API on this. Once you have multiple search spaces operating simultaneously, you get name clashes for the functions, because the function just says, is it a goal state? And it doesn't specify in which space is it a goal state. So the API we have right now is identical to this one, except everything's got one extra argument, which is which state space are you talking about? And I'm not convinced that that's necessarily the perfect way to do it. Or perfect, okay, it'll never be perfect. I'm not sure that's necessarily the best way to do it, so I'm thinking about alternative ways of doing that so that you can use ifdefs. I guess you could still use ifdefs. If you were using a single space, you want to have this API. If you're using multiple spaces, you don't want to have a separate piece of code, right, that's just because you got one more space. So I'm just kind of slightly wrestling with the fine details of the API, but we actually have an API. We have an implementation of hierarchical A star, IDA star, switchback. I don't think we've got the faster one, the sneaky or whatever it's called, but we've got a whole bunch of them: hierarchical fringe search, hierarchical perimeter search. So we've got a whole family of the hierarchical stuff, but I'm not releasing it right now because I want to make sure that the API is the way I like it before I release it. Okay, what's next in the lesson? Okay, so now what have we got? We've got our suck.c is a C file. Think of it as a planning algorithm. We've got our PSVN file. How do we put these pieces together? Okay, so there's a short answer and a slightly longer answer. The short answer is you type make, okay? So that's always the answer in C. In Unix, you always just type make and magic things happen. I want to point out, though, a naming convention that you'll see throughout the lessons. So remember, we've got, let's call it a search algorithm called suck.c. We've got a PSVN file called sliding tile 1x3, and notice the name of the thing we're trying to make. Sliding tile 1x3, so it's got the state space name on the left-hand side of the dot, and it's got the search algorithm on the right-hand side of the dot. So that's a naming convention we're always going to use in all our make files for the lessons. Is if you have a state space called sliding tile, and you got a search algorithm called, let's say, IDA star, you'd make sliding tile.ida. Okay, so that's the little naming convention that you'll see throughout here. Okay, how do we pull these two pieces together? What is the make file actually doing? Well, let me remind you of the compilation approach. Remember, there was two steps. You first of all apply the compiler to get C code for the state space, and then you apply the C compiler to merge that C code with your own C code. Guess what the make file does? Okay, here we are. That's your directory, right? You got your search algorithm, you got your PSVN file. What the make file has got two statements in it, effectively. One of them is to make the C file, and the other one is to invoke the C compiler to bring those two pieces together and name the result according to our naming convention. So I don't know if you guys are make file experts. I'm actually not. But anyway, if the make file is very short, and you should, if you know anything about make files, you should be able to see these two things happening in it. If you don't know about make files, it doesn't matter. Just type this, okay? Just do it right now, and let's see what happens. Where am I? So make, I should have given it a shorter name given my typing abilities.
Mine says nothing to be done.
Oh no, did I?
You forgot the underscore.
Okay. Yeah, try making make clean first, because I actually thought I cleaned out the directories before I copied them onto the disks, but it's possible that I didn't. Okay, so where are we now? Oh, I see what you're saying. Where is this LS?
Still says, I did type make clean. It didn't.
Okay.
Maybe it's just me.
Did you only type make, or did you type make?
I typed make sliding underscore tile 1x3.pdf.
For me, it worked.
No underscore. Maybe that was it.
So there may be a difference in.
So this is what it should look like. This is what it should look like. I'll just tell you what's out here.
So there may be two different versions of the file. So I copied the one from the web, and some of you, I think, have the ones from your USB stick, and some of them have the one from the web. There may be a difference there.
Right. So my problem is I don't have anything that says sliding underscore tile dot SUCC. I have something called sliding underscore tile dot PSVN.
Yeah, that's right. So that's the starting file, and then you're going to run that through the compiler. The make file is supposed to pick that up. Well, maybe I'll come around in a few minutes. I'll just finish up with this, and then we'll have the coffee break, and I'll see if I can figure out what's going on there.
Just type .suck instead of .psvn. That file name .suck.
All right, all right.
Oh, okay. So, okay, right. Yeah. Okay, so everybody got this through. I should have left this up so you could see exactly what to type, I guess, instead of me going off and doing it. So now it's there. It's sitting there. It's an executable. It's gone through the C compiler. The make file took care of that too. So you should just be able to execute that file. It has no command line options, so you just would type exactly what I have here. /sliding underscore tile 1x3.succ. And now it will ask you for input. And because what's it going to do? It's going to read in a state from standard input. And now you can't type that picture. You have to type. You have to remember the domain. I can give you a hint if you. It's a B. Yeah. Well, because every possible instantiation of each state variable with the variables from the values from its domain is a legal state. They're not the states that you associate. In fact, the first exercise, if you peek ahead to the manual, is to it asks you how many successors does BBB have. Okay, because BBB is a legal state. It's just one you can't reach from the normal starting point. And so anyway, so now you have now finished, almost finished lesson number 1. The only thing left to do are these exercises that take you through, I guess we're a little bit over time. Anyway, so I'll just quickly say, I got 2 more things to say. Sorry, we're cutting into coffee, but we don't have to come back on time because I'm not going to talk afterwards. Okay, so the first thing to note is that there's a fair number of exercises for each lesson. You don't have to do them all before you move on to the next lesson. I mean, one of them is like, write a gigantic planning algorithm and stuff like that. So there's some little short ones usually at the beginning that you should do in order to actually make sure you've got the lesson. But then there's bigger ones at the end, and their main purpose is actually just to illustrate what you should be capable of doing. You should feel comfortable that you could do that if you had an hour or 2 to spend on it. So you don't have to do all of them before proceeding to the next one. The things you have to do before going on to lesson number 2 are you really should look inside the successor function code and see exactly what it's doing so you get familiar with how the API works. It's very simple, but you might as well see an example of it. And then I recommend doing exercises 2 and 3 here. They're just simple modifications to that suck.c file to, again, get you using bits of the API that aren't actually in there right now. And the last thing I'm going to say is just a little warning about a domain that I used for illustration in lesson 2. And it's a puzzle that you may not have heard of. Pat will know this because she's old enough, and she was in heuristic search in the 80s. Well, so anyway, it's called the slide jump puzzle. It's actually a fun little puzzle. This is something you can do in the coffee break. If you get bored with PSVN, you can just solve this puzzle by yourself. Okay, so you've got, it's like kind of a sliding tile puzzle, but a little bit different. So you've got yellow tokens and red tokens, and they're in a line of length 7. In this example, it's length 7, and there's an empty one in the middle. And this is the goal state. Get all the red ones on the right and all the yellow ones on the left. And red things can only move to the right, and yellow things can only move to the left. So, and the start state, needless to say, has them on the wrong side. Okay, it's got all the red ones on the left and all the yellow ones on the right. So the idea is to move these two sets of tiles through each other. What can you do? Well, it's called the slide jump puzzle because you can slide and you can jump. Okay, so here's what a slide looks like for a red token. Red tokens can only move to the right. So this is like a PSVN rule drawn as a picture. Is if you have a red token here and a blank immediately to its right, because it's moving to the right, then you can slide it into the blank position. It's like a sliding tile puzzle move. But it can only go to the right. A red tile, there will be no move. It'll take the red tile back there again. So it's a very directed space. You can also jump a red over a yellow. And unlike in Peg Solitaire, it doesn't remove the yellow. I mean, if it did, you'd be dead because you have to get all the yellows on the left. Okay, so it jumps without removal. And so, you know, here's the, just like in Peg Solitaire, you know, there's the red guy. This has to be the opposite color, and there's the empty one. And then the red guy jumps over the yellow one into the empty square, and of course, then that becomes empty. So those are the moves, the only two moves for the red tokens, and the yellow tokens have exactly the same moves, but going to the left. Okay, so now, if the blank is to the left of the yellow, then you can slide the yellow into it, and the jump is analogous. So I just wanted to mention this to you in case you've never seen the slide jump puzzle. That's what it is. And so I'm done talking, and coffee's waiting for us. But just before we break up into is there any questions that anybody has that you want to ask in a group setting? Yeah?
Just one, out of curiosity, how many of the IPC domains have you tried in PSVN? Like, do we have PSVN versions of more?
Real PSVN.
Besides Scanalyzer? That you have manually taken the domain.
There's an elevators encoding, which is one of the ones I like, the elevators encoding, because it uses the equality test. It basically says if the elevator is on the same floor as this person, then they can be picked up. There's a gripper that I think uses the same one. It says if the robot is in the same room as the ball, so it uses an equality test. So there's been a couple of them, but I would actually like to see a lot more of that. It's one of the things, if you feel like, during the next hour and a half, is to pick your favorite IPC domain and code it up in PSVN using the power of PSVN.
I would say that in general, the more interesting ones would be the bigger ones. You know, the ones where the node generation cost is horrendous, like Scanalyzer, Barman.
So there is a Scanalyzer for sure, yeah.
Yes, but I mean, where I guess the PSVN power lies is when the difference between the SAS plus grounded operators and yours are massively different.
Yeah.
That's where it's a no-brainer, you know?
Yeah. So yeah, if that's something people want to do in the next 2 hours, then that's fine with me. I would love to have those, actually. I just haven't got around to doing them. Any other questions for the group? What does it say here? Okay, so I'm going for tea, cup of tea, and you guys are welcome to go too. And then after we come back, I'm not saying a word. So this is now the free form part of the thing where you've got the code, you've got the tutorial lessons, took you through the first one. And so if you don't want to come back, I won't be offended. I would like to get those USB sticks back, though, so maybe you could do that now before we all forget. But other than that, thank you all for coming, because I may not talk to you individually after this, but I'm glad to see the interest that you guys have shown. Thank you.
Thank you for the USB stick.